Hi, good afternoon, everyone. My name's Graham Madison. I'm one of the analysts here at Water Tower Research in our sustainability and industrial practice. As a reminder, this call is being recorded and the replay along with all of our research is available to anyone on our website at watertowerresearch.com. We will be taking questions from the audience. Hopefully we'll have a chance to get to all of them, but my apologies in advance if time does not allow. So with that, just like to start by welcoming John Belizaire as the CEO of Soluna Computing, the operating subsidiary of Soluna Holdings. Just a quick background, John is a very successful entrepreneur, having founded multiple companies, one in insurance software, another in the e-commerce space, both of which were bought by large corporations. And previously, he was the lead architect for Intel's digital enterprise group. He's a thought leader in the renewable energy and Bitcoin spaces, and he's testified in front of Congress. So with that, actually, John, thank you for making the time. We're excited that you're here. Let's start out with the first question. Sort of what brought you here? I mean, coming out of your last startup, you must have had a bunch of different opportunities. What brought you to this intersection of renewable energy, data centers, and Bitcoin?
Well, I would say, first of all, thanks for having me on the Fireside chat. I really enjoy these types of things, talking about our business. The best way to answer that question is really to say that it's a pattern for me. I tend to, if you look at the last 2 decades of my professional career, it really is always the confluence of big technology waves and legacy industries that attract me. My first company was just when the internet was taking off and big brick and mortar banks were looking to go online. And I built a company to help them digitize their storefronts, if you will. My second company was focused on taking enterprise platforms, the back office, and bringing it to the front office. And my most recent was in the insurance space, where underwriting is a bit of an art. We were trying to make it more of a science by bringing the power of analytics and data to the underwriting process. I was introduced to the renewable energy and Bitcoin space. Our major investor is a private equity firm in New York called Brookstone Partners. They had a project in Morocco that was suffering from stranded energy, essentially, and they were trying to figure out a solution to that. And this was in probably one of the best wind regions of Morocco. The grid hadn't made its way there yet, and they were suffering from this problem where they couldn't monetize the energy. And the solution that we came up with through some, semblance of research and analysis was to, combine computing and blockchain type of computing with a resource where we can absorb that clean energy. So that's what brought me here. Here, essentially, it's another confluence, right, where you've got big waves of technology around computing and blockchain and sort of transformational activities, taking, bringing a solution to a problem in the renewable energy space that is also going through its own transformation, right? And so those big tectonic shifts in industry that are catalyzed by big technology is what really energizes me.
Great. What's been different, both in terms of a good sense and a difficult sense?
Well, I think that if you look at the space, I wouldn't say that there are different things. There are actually lots of similarities in my career from looking at insurance and energy. It's what I see that's very similar between the two is that they're both very large industries. They shape the world. I mean, you really can't get anything done without insurance, and you really can't get anything done without energy. I mean, you can't grow an economy, you can't build out, infrastructure and so forth without energy. And so, what's fascinating to us in this journey has been how incredible the volume and momentum of capital coming into the space has been, and more importantly, the fact that the space is really burdened by a little secret, essentially, this concept of curtailment, wasted energy. And we came up with a solution that really is one of those, hit yourself over the head, like why did I think of that? And that solution is very attractive. most of the top renewable energy power producers that we talk to are very receptive to Soluna's solution. It's low risk for them. It solves a major problem that really hits their balance sheet. And so, our hypothesis, which really came from our own experience, is really being validated as we start to develop these co-located projects. So that's one thing that's different, I would say, or surprising to us. The other is how traditional data centers build their solutions, right? They're on a lot of data centers that are designed the way ours are designed. They tend to be large monolithic buildings, have to be on 24/7, focus on customer experience in that way. We're building flexible data centers that are modular, scalable to the size of renewable energy sites. And, I think the focus for us is really on building these highly efficient, sustainably forward facilities so that we can solve energy issues on one hand, and also sustainable IT, which is a big growing challenge. These are all surprises. You just wouldn't, I guess, being a software guy, I wouldn't expect such, sort of exciting, forward leaning, on the edge technology to be taking place in the energy space.
Yeah, the energy space is an interesting one. I mean, it's one of those, and particularly dealing with it, and I know my experience as an analyst and then also working with some of the companies, how slowly it moves. And really it's a matter of, it's just pass or fail. And nobody thinks about energy until it's not on, and that's a failure. So they're very,
100%.
very slow moving and very risk averse, more so than, because failure is not an option in their mind.
Yeah, that's right. That's absolutely right. I mean, you really don't think about energy until you don't have it, right? When you plug
100%.
You plug your toaster in, it better be on. Or your coffee machine is probably more apropos, I guess. But but if it's not working, you're like, what's going on? Like,
yeah, this is a problem. Yeah, exactly. So thinking about cryptocurrencies, they've been in the news as of late, just with the whole FTX and then the impact of mining on the grid and the environment. What are critics missing about this argument or this conversation?
It's a good question. Look, there's been a lot of discussion out there around FTX and all of the downstream collapses that it seems to be causing. It's almost like a virus at this point. And it's just been that one was a major surprise, right, for the industry. And I expect that it will serve as a much needed catalyst for regulation in the digital assets exchange industry. You are effectively, a company that is providing services to people to convert their capital into this new form of financial products. And there's some expectation of trust and regulation and compliance that you should enjoy in the process, because in the traditional finance space, that happens to be true. But one thing I will say is that Bitcoin, which seems to be sort of lumped in with all of the crypto melees that's happening right now, is not the same as crypto. It has not gone down. It has not created a trust issue for the past decade plus. It continues to generate a new block every 10 minutes on the clock, on the time. So every time there's a 10-minute news cycle, that's still happening. And I think that is something that we're missing, the fact that this is a powerful technology. It was built to be trustless, very scalable, transparent, and it's also a very powerful catalyst for the renewable energy industry.
How could adding additional energy to the grid actually help the decarbonization of it or the stability of the grid?
So the idea is that by adding a very specific type of load, most folks don't understand how the grid works. I didn't when I got into the space, and what you need to understand is that the grid is built to be a synchronous system, meaning that on one hand, you have power generation, and on the other hand, you have demand for that power. You have essentially load, as it's called in the energy parlance. There's a direct relationship with between those two, almost symbiotic, right? They're balanced. And therefore the grid can control the output. They've got real knobs that they can use to turn things on and off and make sure that they can dispatch those power generation facilities to match that load and that demand. So in the summer, they can fire up, big generation facilities to do that, and in the winter as well. Now, when you start to replace these traditional legacy fuel facilities, which most of these, power plants are, things start to change. And the fundamental change is that the control, those knobs, are no longer directly powered, by the grid. Actually, Mother Nature sort of decides when there's going to be, wind or sun. And sometimes what you have is a mismatch, right? You have more power generation capability than you have load, or vice versa. And that imbalance creates all sorts of problems for the grid. And grid stability and reliability becomes a real issue. Now, the grid wasn't built for that flexibility. And so there's lots of focus around adding that capability in a retroactive way. So storage is a big approach to solving that. Problem is, we can't store our way to greater grid flexibility, right? Storage hasn't scaled enough. There are other aspects of grid flexibility that have to be addressed. The other is transmission. Right, you can build more lines to move the energy that's being produced to areas where it might be needed. I always like to use the example: if everybody's asleep in Oklahoma and the wind is blowing really heavy right now, maybe you can have a nice big pipe that would just pump that energy over to Atlanta, where everybody's awake, at a party somewhere. Well, the problem with that is those transmission lines are very expensive. They take a very long time, and the grid flexibility benefits of transmission are needed now, not years from now. And but those seem to be the two primary approaches. And the other is just to curtail energy, and that creates a real financial issue for the projects. What we're saying is there's other options that we didn't consider. If you think about it, what you really need is not just fixed load to be added to this solution, to the system when you have extra power. What you want is load that can be flexible in nature. When it's needed, it comes on. When it's not needed, it goes off. And the interesting thing is that in the computing industry, in the data center space, if you take a data center and you zoom into it, there's different types of compute in there. There's real-time compute, and there's non-real-time compute, the compute that can be done in batches, right? You can put it to sleep, it wakes up and does what it needs to do. And more and more of the applications in these data centers are becoming more like that, like these batchable processes. AI and machine learning is probably the biggest growth area of data center computing now. Blockchain computing is a big, fast-moving and growing area. So if you take all of those different types of compute and put them into one facility, then you now have this very flexible facility. And that computing facility, if you design it in a way such that it efficiently converts those electrons to that computing format, you now have essentially a new sponge that you can add, a new rubber band, a new flexing capability that you can add to the grid, that the grid itself can dispatch. So I can turn this facility up, turn it down. If you place it close to the renewable energy power plants, you can absorb that curtailment and use that as your primary source. So computing, the way we like to say it is, computing is better than a battery, because instead of paying to store the electrons, it instantly converts them to an immediately usable form. And that's a very powerful, scalable thing that's available right now. You can deploy this right now, today. And that's what we're doing as a company. We're bringing a lateral approach, I guess, to a unsolvable problem, and putting it to work right away.
Great. And yeah, and just to follow up on your comment, with transmission lines, they are the important thing. You guys can do it right now, today. Transmission lines take a long time to be built.
Yeah,
and now
exactly.
up in Boston, we point everybody to the Northern Pass line, which is supposed to connect hydropower in Quebec down to Boston. That was on fighting over that for over 10 years, and not a single line was built.
Exactly. That's right.
And that's the thing. So even if you had the equipment and everything like that, the permitting process can be really slow.
That's exactly right.
Staying on the grid, you did an interview on your podcast with Sean Murphy talking about artificial intelligence and machine learning and how that could transform the grid and then also sort of shift the mentality in the industry towards one of sort of growing the pie rather than fighting over a fixed share of it. This is going to bring a huge amount of data in. How do you see the benefits to the grid with when these plants and everyone gets so much more data coming from machine learning?
My conversation with Sean was a great conversation. He's a CEO of Ping Things. I think that was a very enlightening conversation. What Ping Things is doing is basically they're retrieving and accessing real-time data from the grid, which is going to be critical if you want to ensure improving the efficiency and flexibility of the grid. Why is that? Because you want to know what's happening at every single node or element of the grid so that you can make the best decisions for load management, power generation, and just like every other industry, when I was in the insurance space, it was all about capturing data and information so you can remove blind spots from the underwriter's decision-making process. The same thing is happening here. By gathering this data, they're basically doing one more instrumental thing, which is making this data, really open and available to all participants on the network. And it's essentially, creating an opportunity to create a collaborative platform for data sources that can help to improve the grid. Once you have a data corpus, you can implement a number of innovations that could enhance the grid. You can, for example, predictively go out and perform maintenance activities on components of the grid that might need it right now because they're getting extra load right now, and that particular component needs an upgrade. You might see pockets of load developing because there's a weather issue in that particular area, and so you want to start firing up more generation to support that. And so all of that is made possible by making data, the best way to describe it is more fluid, right? Almost like, flowing through the network so that you can get more information and remove blind spots for the grid. So I think there's lots of opportunities here, like Bitcoin and other high performance computing activities are scaling quickly. And if we want these processes to be done in a way that's really safe and beneficial for our planet, then renewable energy has to scale quickly as well. And as we discussed, renewable energy brings all sorts of problems to our legacy grid infrastructure. It results in lots of wasted energy. And this deluge of new data will give Soluna so many other players in the space that can essentially provide optimizations for the grid. By using that data in a precise way, we can enhance the grid, bring more clean energy into the grid, and really mend the grid where it's needed. And so I think that's, data has become a very powerful tool for solving lots of challenges in infrastructure and lots of other parts of the world on a real-time basis.
Yeah, and with the energy industry, most of the grid is laid out over 100 years ago and using essentially the same technology. So That's this right. Really could be game-changing when you bring this amount of data and look at it and what you can do. Mm-hmm. So and it's great. Soluna will be right in the middle of that. Looking at some of the listener questions, and I'm going to summarize, but questions around Project Dorothy. And I think in my initiation report, I called it game-changing because it can double your footprint and output. Can you give us an update on where things are in that development and approval process?
Absolutely. So if folks follow our investor site, they can go and download our flash reports, which we publish every month. And in there, we've been giving regular updates on the project. Dorothy is the 100 megawatt built in 2 phases that we're developing down in Texas. It's connected to a big wind farm that's experiencing lots of curtailment. And as part of that process of deploying that data center, ERCOT has developed a number of new processes for these types of data centers, these flexible data centers. It's called the large flexible load process. And essentially there are three phases that you have to go through. The first phase is called planning, and that's where they look at your data center and all of its characteristics, the actual technical design of the facility, and its deployment timing and how big that facility is going to get and how quickly it's going to get that big. And then they essentially try to model into the grid to see if that causes any potential reliability or stability issues. This is super important. They're required by law to do it, both at the state and federal level. There are certain compliance things that they have to do. And as part of that, they perform a number of different studies. They study the flow of electrons. They study how close you are to critical elements of the grid and how issues with your facility might address those. And as you perform those studies, if they're clean, which is the term to basically mean like it's not going to cause any problems, then you go to the next study. And we've gone through every single study to date, and they've all been clean. We're on our last one, which is related to the wind farm's behavior in providing certain important reactive power to the grid. And once that is clear, which we expect that to happen here in the next week or so, we will move into phase 2, which is modeling. And that's where they take your facility and they basically progressively add it to the software model of the entire grid. So the grid operator has an entire software model of the entire grid system. They incorporate your model and they perform a number of tests to make sure that they can see the facility. It doesn't have any specific issues. And those are all very, obviously secret and proprietary things that they have to do there. And then eventually the model becomes live. That can take up to about 90 days to perform. We're already in the model system. It's just waiting for us to clear planning. So based on those two stages here, as we enter, squarely into modeling, we expect that we'll be essentially green lighted to energize here in the first couple of months of the next year. That's where we're currently sort of tracking to. We can't give the exact date on this conversation, obviously, for all sorts of reasons that are security in nature, et cetera. But when we do get the green light, then we'll put that out there. But this kind of gives you the time frame of sort of what we're talking about, and we're tracking pretty nicely to that. Phase 3 is operations. So once you clear modeling, you're now in the live model. The ERCOT organization gives you a green light to then go energize. They look at to see that they can actually see your load running. So, I've been in one of these control rooms and there's these giant screens and they have like pretty much they can see every part of the grid in detail. It's amazing. And they basically say, yeah, we see your load. It's running pretty well. You can go ahead and fully energize. And that's that third phase where you start to ramp up your consumption, and we can ramp up to the full load level based on our ramp up plan. So I'd say, right now where we stand, we're a nice pathway to getting the project energized, and we feel pretty good about it.
Great. Another question, what type of computing will you be doing at the site when it goes live? And do you have a long-term thoughts on that, both near-term and long-term?
Absolutely. This is great. So the standard practice for us is to essentially bootstrap each facility with Bitcoin mining. The reason is because, number one, it's got these properties I talked about, dispatchable, you can pause it. And, our business plan essentially calls for then expanding those facilities into a broader set of computing within the high performance computing market. So this means, we'll partner with enterprises in the AI and machine learning space, scientific computing, video rendering, and beyond. And there is significantly more capital available for what we call our phase 2 business. And that's why we're excited about it. The total market is potentially over $100 billion, including crypto. And the batchable market is multiple times larger on a per unit basis, energy basis, compared to crypto mining. So think about sort of dollars per megawatt hour that you can earn is significantly higher. So there's lots of incentive for us to expand our facilities to be diverse facilities to support these different applications. every single one of our facilities are already designed today for this type of batch processing. So the electrical design, the design of the buildings, everything about the footprint, our control systems are all focused on this much larger market opportunity. And so, I know there's some shareholders on the call potentially, or folks who are just getting to know us. I don't want you to see us as just a crypto mining company. The way to really look at it at us is really a green data center company that is starting in the crypto mining space and then eventually expanding beyond that and providing a real solution to a big problem in the renewable energy space. And that's, wasted energy. That's what we're going after. And we want that problem to go to zero such that we can have more green electrons flowing on the grid on a global basis. And the way to do that is to have an entire fleet of these facilities that have a whole host of different type of computing that's resilient to, what's happening in one particular space versus the other, and can allow us to scale and go after this problem in a big way.
Great, thank you. So we're coming up at the 12:30 mark, so I have time for one more question. What do you think investors are missing or misunderstanding about Soluna?
Yeah, I think that was the comment I just made. I really want the investment community to look at us as a new digital infrastructure company. We're building a new form of green data center that solves a major problem in the renewable energy development space, and it also solves a big problem with computing in that it needs to be more green. I really see the company as being on the vanguard of renewable computing, if you will. For us, renewable computing is really a form of computing that creates additionality, that brings more renewable energy online because we exist. We design and implement our data centers to not just be green in name, but probably the most efficient in the industry, paving the way for, I'd say, reimagining the future of cloud computing. Why can't cloud computing be a catalyzer for renewable energy growth? And we want to power high intensity batchable processes like the Bitcoin network, video transcoding, and all these other things that I talked about. Things like deep learning. There's now AI art. I don't know if you've seen this, Graham, but there's like AIs. You type a sentence, John on the beach. And it'll come up with some, it'll come up with some, in crazy, amazing art. And it's very compute intensive, actually. And it's become a big driver of growth on the cloud space. But what's interesting, though, is for Bitcoin to go mainstream, it really needs to be more ESG friendly. And so in a way, we're sort of creating a way for that to happen. We've been able to sort of combat the dirty Bitcoin narrative because, we've built really the perfect recipe of integrating it with renewables. And we're not just Bitcoin. We're going to do that for other types of applications and processes as well.
It seems like, if you look at other industries, in the beginning, they were all very energy intensive, but they become much more efficient very quickly. Is it fair to say that this is the same, that Bitcoin or any sort of crypto would probably follow the same similar trajectory?
Absolutely. Moore's law is still very much alive. Computing and processes innovate over time. It's just the nature of technology. I always say that, look, in my 2 decades of experience as an entrepreneur, I've seen it time and time again that you just cannot underestimate the power of technology. It can, exponential technology, more importantly, can creep up on you. So renewable energy is exponential technology. Computing is exponential technology, meaning that, every time you double the footprint of a particular technology, its efficiency, its cost goes down significantly, and it's usually a straight line. And so as we have more of these facilities, more of this footprint out, more renewable energy, the cost of all of it will start to come down. The efficiency of it will improve, and they will be really sort of catalyzers for each other. Like, it'll drive growth for both industries. And I think that's really amazing. And I think is going to catch us by surprise. It's suddenly going to be sort of one of those things where everything I'm talking about right now is really exciting. And, in 5 to 10 years, it'll be really boring because it'll be so ubiquitous that it's just like, sometimes I walk down New York streets in New York and I see a phone booth and I'm like, oh my God, look at this, And my daughter's like, what is that? I don't know why do you need a phone on the street, Dad? And it's like, good question. Now I can call anybody in the world from a device in my pocket. That's the power of exponential technology. And that's what excites me about what we're doing at Soluna. We're building the next generation of that.
And that, just to follow on that point, I mean, I think it was in your podcast you talked about, think about things like the applicant, like Waze or other things like that. That could never have happened without the iPhone. So it's sort of one catalyzes the other, and
That's
things that we've not even, couldn't even imagine now will become so commonplace in a few years that we can't.
That's exactly right.
Yeah. How did we live without it?
Yeah. How did we live without it? Yeah.
How did you go to school without the internet? It's like, all right. That's it.
All right. Let me.
So.
Exactly. Yeah.
All right. With that, we are out of time. Thank you so much, everyone. Again, the recording will be up on the websites, and we'll be following up with the management series in the coming days. Thank you, John. Appreciate it.
All right. Thanks, Graham. Appreciate it.